simplifying expressions. And the difference between an expression and an equation, of course, is there's no equal sign. So we're still going to work with expressions for the time being. But now, instead of multiplying and dividing, which is just simply cross tops and the bottoms, you want to reduce it like a fraction. Now we need to add and subtract, which means we need common denominators to get the expressions. And then once we get them over a common denominator, then we reduce them by factoring and cancel out where we can. One of the things they do is they use it's a kind of a Venn diagram style of method to get your common denominators. So for instance, if I was trying to find a common denominator between 12 and 8, let's say, okay? So we put the factors of both of them that go in the middle. So what are the factors that go into both 12 and 8? 4, and that's 3 here, right, and 2 here. Okay, so those are all the individual factors of this. Well, those individual factors, if multiplied together, give me the common denominator when we do this. So if I didn't do that, what's the common denominator between 12 and 8? 24. So I go 3 times 4 times 2. So it gives me 24. So we would never use that per se when we do just simple numbers. But when we're doing expressions and polynomial expressions, we will sometimes use that, and it makes it a little bit easier for some. Okay, so today, well, first of all, let's just look at a typical question. 3/4 plus 5/6. Okay, I need to add those together. What needs to happen here? Raise what? Sorry? Lowest common denominator, right? So what do 4 and 6 both go into? 12. So when I do this, I look at it and I say, okay, well, I need it over 12, right? So what do I have to multiply 4 by to get to 12? 3. So whatever I do to the bottom, I have to do to the top. So I do it like that. Okay? Now, of course, I don't need to go through all this process when I'm just using numbers. But the process itself helps when I'm using polynomial expressions. Okay, and what do I multiply 6 by to get to 12? 2. So I'm 2 over 2, like that. Okay, so this gives me 9 over 12 plus 10 over 12, which is equal to 19 over 12. Okay, so simple enough. That's how we've always done this. That's how we've always added fractions. The process, again, of doing this, you didn't have to do. All right? Most of you can do that in your head. I got times 4 by 3 to get to 12. 3 times 3 is 9. You just go that way. But what happens when we have expressions? That's what we want to see how we do this. Okay, so first expression. And again, much similar to what you were doing the last couple days, I want to break it down first, if I can, and factor things. Okay? All right. So, just looking at this one. Common denominator here is what? X squared minus 9. So, I'm going to write that along the bottom here. And since both of them are already over x squared plus 9, I don't have to do anything. So I go 2x plus 4, add, and I'm going to put that in brackets, 7x subtract 10, also in brackets. The reason I put it in brackets is if I'm subtracting, I sometimes forget to put the negative through. So I'm leaving it like that. Okay, now let's simplify the top. 2x and 7x make 9x. 4 subtract 10 is negative 6. So that's over x squared minus 9. Okay, so now my next step might be to see, is there a possibility that I can still make this lower or break this down more? Okay, so I could take a 3 out of the top, which would give me 3x minus 2, agreed? Over, and the bottom would be x minus 3x plus 3. But I can't cancel anything else, so I can either leave it as this, or this is fine. but you're going to want to check it. All right, what are the non-permissible values in this question? 3 and negative 3. So I also have to include those. So comma, x can equal plus minus 3. All right. These do get complicated. They do get complicated. The first, when you're just multiplying and dividing, they're pretty easy, but these can get complicated. So let's look at our second one on that page. So we have 10a plus 5 over ab minus 3a subtract 2 over ab, right? Do I have my common denominator already? Yeah. So it's all over AB. Okay? And this is why I said I would strongly suggest putting brackets is because of that subtract. I need to move the negative through the brackets. Okay? So I have 10a subtract 3a, which is 7a. I have 5 add 2, which is 7. So AB could factor out a 7 and leave it as a plus 1 if there was something to cancel on the bottom, on the top, but I don't need to. I can leave it as this, and what are my non-permissibles? A can't equal 0, B can't equal 0 either. Neither one of those values can equal 0, or you'll get an undefined value. Okay. Any questions about this so far? Like I say, it will get more complicated. Let's look at the working example 2. So this is where they start to use that Venn diagram idea, or the circle idea, to get your common denominators. Can somebody give me the common denominator for 2x, 3x, and y without doing... So just take a look at 2a. 2x, 3x, and y. Does anybody know what the common denominator for that is? What's the lowest common, or what's the common denominator between 2 and 3? 6, right? And 2 of the 3 terms have an x, so we know that has to be a part of it. And one of the terms has a y. So it would be 6xy, all right? So what they're going to do then is they're going to break this up. They use actually 4. Gotta make sure I read this right. 2. Oh, they just used 3. Okay. So looking at 2x. So denominator number 1 is up here. So it's 2x. Denominator number 2 is 3 and x, right? And then denominator number 3 is just y by itself. That has nothing in common. Okay? So this is denominator number 1. This circle. This circle represents denominator number 2, and this circle represents denominator number 3. Now that I've got it broke up, I can just multiply it all together, and that gives me what my common denominator is going to be, which is 6xy. Now, for some of you, if you like this method, by all means do it. If this makes this easier for you, then do it. Okay, so I'll do a couple more so that it makes more sense for you, but I'll show you how to do this. I don't care for it, but that's my own opinion. Some of you will be able to just do it without. All right? So let's look at that second one. I like the second one a little bit better. I'll make it bigger. There's denominator 1, denominator 2, denominator 3. Okay. So we're breaking it up. So this is why, again, this is why I would factor first. I always factor first with my denominators for 2 reasons. Number 1 is it gives me my non-permissibles. And number 2, it helps me find my common denominator quicker. All right, so when you compare denominator 1 and denominator number 2, do they have anything in common? X plus 5. So that goes between the two of them. What's left with denominator 1 if I put x plus 5 here? Nothing, right? 1. Okay, so I can leave that. Denominator number 2, however, has another piece to it. What is it? X minus 4. So I can stick that right there. Okay? What about denominator 1 and denominator 3? Is there anything common between the two of those? 1 and 3. 1 and 3. So between these two? Nothing. So I don't need anything in here. Okay? And there's nothing common between all three of them, right? So now I'm left with what's common between D2 and D3? X minus 4. So I'm going to take this guy out of here. Put him right here. So denominator number 2 is x minus 4 times x plus 5. Agreed? Denominator number 3 is x minus 4 times x plus 7. So there you have it. What are the three expressions that I'm going to use for my denominator? Right. Okay. So here's my next question. Now, I don't know. I find this might be something I should be doing better because I have a hard time explaining this to people. And I don't know, I can't seem to get it to make sense for everybody. So I'll do the best that I can right now. So let's say that I take that B. So everybody look at B right now. Because this is the meat and potatoes right here. Let's say that my denominator is going to be exactly that. Okay, so this goes back to my original, when I did the fractions, multiply top and bottom. When I look at x plus 5, 1 over x plus 5, what are the two expressions I'm missing out of that to give me the denominator? This is the question that I have a hard time asking to make it make sense. I want to change 1 over x plus 5 so that I have the same common denominator as the other two, sorry. So what do I have to multiply x plus 5 by to get this whole thing on the bottom here? Yeah, but that's not the question I'm asking. Because, okay, let me do this again. This is what I mean. I don't want to start this off on a bad note without, let's do this differently. Okay, we all agree what my common denominator is, right? So I want to get x plus 5 to x plus 5, x minus 4, x plus 7. Okay? Now I got it. So what do I times this by to get to that?
Multiply by s negative 4 and s plus 7.
Yes. So whatever I do to the bottom, I have to do to the top. Agreed? So I'm going to times the top here by x minus 4, x plus 7, like that. Okay? Let's look at the second one, and maybe it'll make more sense. What's the second term? 1 over x plus 5 times x minus 4. Okay? Now I want it to get to this. So x plus 5, x minus 4, x plus 7. Okay? What do I have to multiply the top and bottom here by to get to that? X plus 7. So I'm going to times it by x plus 7. Is this starting to make more sense now? Sort of? Okay, yeah, Rex, go ahead.
So, if you're just doing like the first two on A and B, you just multiply the top of A by x negative 4. Because instead of dividing,
Yeah, yes.
2.
Yes, that's right, Rex. Yeah. Okay, so now looking at this again. Now we're doing a pretty complicated one to begin with. I'm throwing it at you because I want you to see if we can pick it up at this point. What do I have to multiply this by top and bottom to get to there? Okay. So, to go back to what I was doing earlier. Go back to what I was doing earlier now, okay? I've got all of those three terms over the same common denominator, and then what goes across the top? X minus 4, x plus 7, plus x add 7, plus x add 5. So, look at B now. I had 1 over x plus 5. I had 1 over x plus 5 times x minus 4. I had 1 over x minus 4 times x plus 7. And I want them all over this common denominator. So I have to times the first one by x minus 4, x plus 7. I have to times the second term by x plus 7. And the third term I have to times it by x plus 5. Now I would multiply out and simplify the top. Okay, that's where we're going. You're not here yet, I get that. But I figure if I show you this now, we can work backwards on the easier ones and work towards this.
Don't you have to find a common denominator?
There is my common denominator right here. That's it. Okay? Now, let me show you. I want to explain that. If I asked you to do this, and I asked you for the common denominator, if you didn't know what it was, what could you do? Multiply the two numbers and you'd get it. Right? Might not be your lowest common denominator, but it's a common denominator. That's what I would do here. So I would times this by 4 and this by 3, agreed?
Yeah.
And I would end up with 12. I'm doing the same thing here, multiplying by everything. Okay? So, I'm going to come back to this. But not for a little while. I want you just to keep working here. Alright. So now let's look at C. So what's the first thing I suggest you do every time? Sorry? Factor top and bottom. Factor it out to make the expression in its lowest terms. So the bottom one there, first one factors to x plus 3 times x plus 3, right? And the second one factors to plus 3 x plus 5. Is that right? Okay. We all agree with this? Okay. Let's use our bubbles. Denominator number 1, right here. Denominator number 2, right here. So D1, D2. Any crossover between the two denominators? X plus 3. So I stick that right here. What's left under denominator number 1 then? X plus 3. So that's important. We got to leave that. And then what's over here then? X plus 5. So what is my common denominator here? Yes, all three of them. Now yes, I can write this as x plus 3 squared. You can do that. But I write it out in their lowest terms so that I see that I don't miss it. Okay? So now, we all agree this is the common denominator? Anybody, oh, that's nice. Anybody not understand what I did here?
You just go through it slowly again?
Yeah.
Okay, so the first thing I did was factor this and factor that.
Yeah, I get that.
You get that? Alright, this is my denominator right here, x plus 3 and x plus 3, right? So out of this denominator right here, is there anything that's the same here and that's the same in this denominator?
X plus 3.
So it's got to be, you're going to struggle with this, Eli, because we struggled with this before. It has to be x plus 3 in brackets. So you were right. You're correct on this. Okay? But it's not, before you would have told me an x and a 3 and not x plus 3. Okay? So x plus 3. There's an x plus 3 here and an x plus 3 here, right? So that goes in the middle. That's what's common. So what do I have left of here if I take the x plus 3 out?
Another one.
Another x plus 3. And what do I have here if I take the x plus 3 out?
X plus 5.
X plus 5. So then my denominator then, that's common between the two, is x plus 3 times x plus 3 times x plus 5.
So how would it work when you have like 4 or 5 bubbles? You just go in that
A lot
order?
more difficult. It would be a lot more difficult. But I did do that already.
Yeah, I see.
This one. So denominator number 1, 2, and 3. So what's common between 1 and 2? Well, x plus 5 was. What was common between D2 and D3? X minus 4 was. And then what was left over? X minus 4 here, x plus 7 here. Okay, so
I sort of see that too. Thank you.
you're only going to work with 3. You'll never work with more. Okay? So now, here's my next question then. If this entire thing right here is my common denominator, what do I have to times the top and bottom here by to get to there? X plus 5. And what do I have to times the top and bottom here by to get this x plus 3? So then, if I was actually adding these together, I would go x plus 3, x plus 5 like that. And then my common denominator would be, don't write this out, I'm making a mess of this, don't write it out. It would be all of that. So it would be all over top of that, and then you would add those together on top. Okay, but again, I'm not there yet. I'm just showing you. Okay, so we'll keep working, all right? This will be the toughest part of this whole section. Okay, have a look at working example 3. Okay, so I've got x minus 15 over x minus 1 plus x minus 4 over x plus 1 okay. How many of you like the bubbles? Does anybody like the bubbles? A couple of you? We'll use them then. Okay? The bubbles work very effectively. The bubbles work very effectively for 2 denominators. They're not confusing. Right? So if I do it like this, here's denominator number 1, here's denominator number 2. What do both 1 and 2 share? Oh, I got a mistake in this. No, you're right. That should be 1. So what do they both share? What do they both share? So that goes in the middle. Is there anything else with the first denominator? X. Anything else with the second? No. So what's my common denominator? X times x plus 1.
Is it time you add? So the other ones you add.
I never added anything.
Just the top.
Just the top. The bottom is all multiplication.
Yeah, I know.
Does that give me 7?
No, I know. What you said.
So I don't do it here either. Okay, so now my denominator is x times x plus 1. Do I have to multiply the top here by anything to get the bottom to be the same as this? No, so it just remains x minus 15. Great. Okay, what about up here? Do I have to multiply this by anything? By x? So I go plus x times x minus 4. So I get to there. Okay? This guy wasn't missing anything. That is my denominator, this here. This guy's missing an x on the outside. So I got to times the top and bottom by x. You get that? Anybody not? So I'm going to times the top by x and the bottom by x. That way I get to x times x plus 1. Whatever I do to the bottom, I have to do to the top. Yes, Rex?
Would you ever try and get rid of the x and just keep it as x plus 1? For the
No.
denominator?
You have to have everything in its entirety. It's going to change when we solve questions, which is going to be lousy, but for right now you keep everything. Because we're still working with expressions and not equations. Okay, so at this point then, Leave the denominator as is. Now I need to simplify the top. That's going to give me x squared minus 4x, add x, subtract 15. So I transferred this x through the brackets, x times negative 4. Now I've got x squared minus 3x minus 15. Are there any factors of negative 15 that add to give me negative 3? No. This is my final answer. What else do I need to have there? Non-permissibles as well. 0, negative 1. Okay? I know there's a disconnect from this to that. There always is. So I'll try and keep doing this with you until I can make it make sense. Alright? Okay, so let's try this last one. 6x over x minus 5. Subtract. What's on top?
240.
240 on top.
X squared minus 2x.
Can you factor it for me, Rory?
X minus 3x.
X minus 3, x.
No, x plus 3x minus 5, sorry.
Good. You guys all agree with her factoring? Okay, so since last Friday, and Monday and Tuesday, you've now seen the stress that comes with factoring and being able to do it quickly, and there's a lot of it. You will do this over and over again from here on in, grade 11 and grade 12, you'll do a lot of factoring. So we have to nail this. You have to do it quickly. You can't struggle with it. So you've got to practice, practice, practice. So if you need more practice, let me know. All right. Do we want bubbles here? Sure. Okay, so bubble number 1, denominator number 2. So D2, D1. All right. What are my parts of D1 and D2 that are the same? Elijah, what is the same in those two?
X subtract 5.
So that goes in the middle. Is there anything else that goes with D1?
No.
No. What about D2? Is there anything else that goes with D2?
X plus 3.
Okay. So looking at what I just wrote on the board in those two bubbles, what is my common denominator?
Subtract 5. X subtract x plus 3.
That's right. Okay. So now, I'm going to do this in one fell swoop. All right. Do we all agree that that's the common denominator? Anybody not know how to get to the common denominator? Be honest, please, because I'm telling you right now it's going to get complicated if we can't do this. Does anybody not understand how we got the denominator? Okay. Now, my next question to you is this then. How do I go from x minus 5 to this? What do I have to times it by? X plus 3. And whatever I do to the bottom, I've got to do to the top. So I'm going to take 6x and I'm going to times it by x plus 3 on top. Does everybody follow that step? Anybody not? Put your hand up if you don't understand. Seth, you good? You following this? Anybody not understand what I did there? Okay. Subtract. Do I have to times this by anything to get to there? It's already there, right? So whatever's on top just stays as is. So that is 240. Okay? Everything okay? Questions? You guys like the bubbles? Yeah? Most of you are okay with bubbles? Alright, good. Alright, so now what do I have to do next? I have to simplify the top part. So what do I have to do to simplify it? Times the 6x through that brackets, right? So what does that give me? 6x squared plus 18x minus 240, right? Over x plus 3, x minus 5. Okay. So far so good?
Can you just factor?
We can check it. We should check it to see.
Because you can get x squared 3x.
Okay.
Negative 40.
No, 40. You're
40?
right. Yeah. Okay, so we go 6. We gotta leave the 6 in there because it's an expression. So x squared plus 3x minus 40. Like that, right? Okay. Can you factor that?
X plus 1
That's 8 and that's negative.
That's right. 6. X plus 8. X subtract 5. Over x plus 3. X minus 5. Right? Yes, you can. Can I simplify this fraction now? Yeah. X cannot equal negative 3 or 5. All on the denominator. Alright. Only the denominator can't be equal to 0. I have to include the 5. Have to include the 5 as well as the negative 3. So my final answer is 6 times x plus 8 over x plus 3. X can equal negative 3 and 5. Okay? So factoring, factoring, factoring. That's all you're doing right now with these expressions. Alright? Okay? The hard part is the common denominator issue. Alright? Adding in the common denominator at that point. Okay. So that covers all of 6.3. Okay, take a look at your 6.1 and 6.2. You worked on that on Monday and Tuesday when I wasn't here. Are there questions in there that we want to look at? I fully expect you to be done 6.1 and 6.2 and on 6.3 today. If you're not where you need to be. Rex, go ahead.
Did you do number 10 on page 250?
250, number 10. Model the situation using a quotient of rational expressions and then solve. Sphere is contained inside a rectangular box such that the sides of the sphere are touching the sides of the box. What fraction of the volume, so we need a fraction, of the box does the sphere occupy? Model the situation using a quotient. So we have to compare the volume of the sphere, volume of the sphere, to the volume of the box. Okay, so far? Alright, how do I find the volume of a sphere? What's the equation? Does anybody know?
The sphere?
Sphere.
4 pi r cubed over 3.
Yeah. Okay, so it's 4/3 pi r cubed. That's the volume of a sphere. How do you find the volume of a box? Length times width times height. All right, take a look at the picture. What is the length of one side of that box?
Same thing goes down.
Take a look at the diagram. Take a look at the diagram. What is the length of one side of the box? Sorry? Yeah. Yes. So how would you write that? No, not square, just double the radius. How would you write that? 2r. So, and you agree that they're all the same length, right? So 2r by 2r by 2r. Yes or no? Yeah? So I've got 2r by 2r by 2r equals. So far so good? So all I've done is just find the volume of a sphere, find the volume of the box. So that leaves me with 4/3 pi r cubed on top and 8r cubed on the bottom. How are we doing so far? Okay? Alright, what can I cancel to begin with? R cubes cancel, so no longer have variable. So now I have to reduce 4/3 pi over 8. Okay? We'll leave the pi as part of our answer. Now I need to know what 4/3 over 8 is. Yes. So this is what I have right here, 4/3 divided by 8, which is the same as 4/3 times 1 over 8. Because it's 8 over 1 right now. Right? Okay? That cancels and that cancels and leaves me with 2 on the bottom. Agreed? 4 goes into 8 twice. So your answer is 1 pi over 6. There's your answer. Okay? I would expect you to get to here, including canceling out the R cubes. Just by writing out your formulas. I expect you to get to there. The pi over 6 part, probably a little bit tougher if I tell you you have to leave it as a fraction and with exact value, meaning you leave the pi there. Most of you are going to take this and use your calculator, which is going to be a no-no. So we want to do as much as we can without. But anyways, there's that question. Okay? All right. Other questions from 6.1 or 6.2? Again, if you're not, you need to ask these questions. You cannot be shy about it. Eli.
4b.
What page, Eli?
236.
4b.
With the denominator. How do you factor that?
What's the very first thing that you learn about factoring?
You got a squared value.
Say that again?
Your x is squared.
No. No. Okay, so what's the first thing you're supposed to look for when you factor?
Your product.
It's the number one rule to factoring. Greatest common factor. It's the very first thing you do every time you approach a question is look for a greatest common factor. What's the greatest common factor there?
6.
There's a 6 in both those terms.
Okay, next.
Do you understand what greatest common factor means?
Yeah.
Do you?
Sort of.
No, you don't. Because if you told me 6 there, then you don't know what it means. So, let me do this again. What's the greatest common factor between 8 and 12? Do you know what greatest common factor? Yeah, okay, so do you know what it's asking, what I'm asking you? What am I asking you?
What both of them can go into?
No,
What, you can multiply both of them to get the same?
no. You don't know? What number goes into both of them? And when I say greatest, that means highest, largest, biggest. What is the largest number that goes into 8 and 12? So you had it right, you said the right answer, but you don't know what that means. So we need to know what that means. So what is the largest number that both can go into? In this case, it's 4. Or the largest number that goes into both. 4 goes into 8, 4 goes into 12. That's your greatest common factor. Okay? What value goes into both of those?
X.
X. When I factor an x out, that means I'm dividing each of these terms by an x. What am I left with? X squared divided by x leaves me with what?
6 over x.
X squared divided by x leaves me with what?
X.
6x divided by x leaves me with what?
6 over x.
About 6. What's x divided by x?
Nothing.
It's something. What is it?
1.
1. So when I divide this 6x by x, this x, what am I left with?
6.
Just 6. Okay, now look at it in a different way. What do I times this x by to get to x squared?
X.
That x. What do I times this x by to get to 6x?
6.
6. So that's what I'm left with. This is factored. Look at your denominator. You just factored it.
Okay.
Got work to do. Okay? Alright, so what is the first thing that you need to do when you do factoring?
Greatest common factor.
Greatest common factor. Doesn't matter if there's 3 terms. Okay, take a look at D now. Did you do D?
No.
No homework done the last 2 days? If you were to factor the top part of D, what would you take out?
6 and then 6.
Yes. Alright? You take 6 out, that'd leave you with x squared plus 3x plus 2. Okay?
Thank you.
That's alright. Alright? These are things that you're going to have to work on, but you are not past 6-1 yet? What did you do for the last 4 days? 5 days? Okay. You gotta get going. You need to be on 6-3 today. And realistically, if you can do 6-3, you can do 6-1 and 6-2. They're the same thing. They're just harder. So once you get a rhythm, then get to 6-3. Okay, any other questions today? Okay, the rest of the day to work. Yeah.